Hello. Hi guys, good morning. Welcome back to a new video. Ki hal chal? I hope you guys are doing good. In this, we're gonna see a problem. Max sum of pair with equal max sum of a pair with equal sum of digits. Again, company tags and stuff you will be able to find on the channel website. Now it simply says that you are given zero indexed array nums and it consists of positive integer only in which I can choose two indexes I and j, which means out of this input array I can choose any two indexes I and j such that firstly the indexes should not be same and the sum of the digits of number nums of I is equal to the nums of j. So technically I have to maintain sum of digits and that's what I have done. So I have maintained, okay, for 18 the sum of digit is 9, for 4 3 it is 7, for 3 6 it is 9, for 1 3 it is 4, for 7 it is 7. So I just have maintained sum of digits because it is required by the problem itself. Now the prime task here is find the or return the maximum value of two numbers at two different indexes that I can obtain over all possible indexes I and j that satisfy the condition. What is the condition? The condition is that the sum of the digit of the numbers nums I and nums j is equal, which means that I have to choose, let's say sum of digit is 9. Okay, I will choose this number 9, this number, and out of all such values which have a sum of digit as 9, I have to take two values out and with that I have to add their sum and get the answer. So as you can see in this, either I can take 18 plus 36, right, or I can take 43 plus 7. Why? Because their sum of digit is same, so I can make them as pair. I can take 43 plus 7, and there is nothing I can make with 4 because there is no one else having the same sum of digits, so nothing can be made. Now out of these two, which has the maximum sum? All obviously this has the maximum sum, thus the answer is 54. In this case, the sum of digit is 1, the sum of digit is 3, the sum of digit is 10, the sum of digit is 5. I don't find any another number having the similar sum of digit, thus I cannot form a pair. Answer is -1. So, first very basic thing which comes to our mind is that we are trying for all possible ij pairs. So, if I say all possible ij pairs, I can try something of this sort. Let's say I is here, j is here, then my j will be here, then my j will be here, then my j will be here, and so on and so forth, and so on and so forth, which means I am trying for all possible ij pair. Now for a specific ij pair like this, if their sum of digit is different, there is not even any possibility of comparison, so simply move on. And when I say move on, let's say if I'm comparing now this I and j, now the sum of digit is same. In that case, I will try to maximize its nums of I plus nums of j and ultimately give the maximum nums of I nums of j. So with that, what is the complexity? The complexity will be O of n square, because obviously you will have to you will have to maintain that all entire ij pairs and comparison. With that, you might end up taking all these numbers, all these pairs. Now space, depending upon how you implement it, but obviously you can do this pre-computation per se, that for every number just maintaining its sum of digit, or maybe you can find it on runtime as well, that while I'm iterating on I and j on runtime, I can just iterate on the digits, and if I say digits, I can easily see that I have, okay, where is my constraints? Okay, the constraints is not visible here, but I had the nums of I as up till 1e9. It was up till 1e9, which indicates that I can have at max 9 digits. So if I have to get the sum of those 9 digits, it will take O of 9 time. So even if I compute the sum of digits on runtime, that will take O of 9 time, which is constant. So I can simply say it is roughly constant. And again, the space will be O of 1 because I'm not using or maintaining any hash map, just to maintain a mapping from number to its corresponding sum of digits. Now, can we improvise it? Obviously we can, because we easily realized that we only want, because it is unnecessary that I go on to all the ij pairs. It's strictly unnecessary. I can do one thing. I know that, okay, 9, because a sum of digit of 9 has a number 18. So this is one. which can be paired with only another number having same sum of digit, which is 9. Again, it can be only paired with another number having the same sum of digit, which is again 9. Same way, for 7, I can pair it with another number having the same sum of digit. So now you can see that I was able to make some groups. Now I know that either my answer will be from this green group sum of two numbers, right, or from this blue group sum of two numbers will be my answer. Now the question is that out of this green group, obviously I can have, let's say, n such elements in the green group. So how will you find out that which two elements to choose such that their sum is maximum? Obviously, there's a standard phenomena that if you want to do an addition, want to maximize their sum, try to keep both individual elements as max as possible. So as to get from the green group, if I have to get the maximum sum, I will try to pick up the maximum number. So in my green group, I have 18, I have 36, I have 63. I can simply sort it, or maybe if you want, if you can sort it, or if you want, you can take the two maximum elements, again maximum and second maximum. For that, sorting is not required, but again naively you can maybe sort it, or without naively you can take maximum and second maximum and take these two and take these two and just get the answer for green group, or for green group, this is the maximum sum which I can get. Now do the same for the blue group. For blue group, I have carried 43, 7, 25. Let's say if I find the maximum and second maximum, I will simply add it, and this will be my blue group answer. And this will be my green group answer. There is nothing which this 4 can give because the group size needs to be more than equal to 1. Sorry, more than equal to 2. So in that case, I can simply maximize out of this 43 plus 25 or 36 plus 63. I can easily see that this is more. So my answer will be 99. And this is how I can go about it. So what you did here, firstly, you have to maintain the corresponding groups. You can say that firstly, for each and every summation, I will maintain what all elements are there. So I can maintain, okay, for the digit sum of 9, I can have 18, 36, 63. And then for, let's say, my digit sum of 7, I have 43, 7 and 25, and for digit sum of 4 I have 13. So this is what the group is represented by. Now, as a very naive case, you can sort this group and take the last two elements, or if you want to apply much brains, you can take maximum and second maximum, maximum and second maximum, and then add them. And when you are iterating on each group, which means that you sorted the group, took the last element, or maybe you took the maximum and second maximum and added them, you can simply maximize, okay, for this group this is the answer, for this group this is the answer, for this group there is no answer. So maximize the corresponding answer which you can get and ultimately get this solved. So what you did, obviously you will have to maintain some kind of a hash map that for each digit sum what all possible values are there. So like if I say the space required will be O of n, because you will have to maintain that. Now time required, obviously you will have to make the corresponding groups, so that's just O of n traversal. But after making the groups, you might have to sort it, which might take O of n log n time. But if you apply brains here, then you might actually get it in O of n time, which means taking the max and the second max, which means simply iterating on this group and taking the max and second max. Now again, taking max and second max, because just to achieve that in O of n time, it's pretty like overkill for just a very small problem. Because if we look, we just needed this thing, that adding two numbers should give me a higher value. So I will always try to choose a higher number. That's it. So what I can do just to simplify my approach is that I know that for a number 9, I knew that its group should like, again, whenever I am at a specific number, I will find its digit sum, and after getting its digit sum, I should look back and check with the same digit sum, what is the maximum, nums of I which I have available? Because obviously I know that if I am at a specific number and if I want to get the maximum sum, I should make sure that other number is as max as possible. So what I did, as I mentioned, I did, okay, for every digit sum, maintain its previous max value found. With this, let's proceed and see how we can solve it. So let's start. Okay, now I am here at the first number. Firstly, I will try to find its sum of digits. Obviously, I can find that in O of 9 time, right? Or maybe in worst case, you can say O of 10 time. So this is how I can find the sum of digits for it. Now, when I found it, I will check in my hash map. My hash map will, let's say digit sum map. So for digit sum map of digit of 9, is there anything available previously? Previously? No, there is not. Okay, in that case, I cannot make any pair. I should proceed forward. But before proceeding forward, make sure that for 9, you update the corresponding nums of I, because this will be used in future. Let's proceed forward. Now I am at 43. I will again say that for 43, find me the digit sum. How I can find the digit sum? Simply, it's a simple loop. Just get the last digit, add a 3, just remove it, just get a 4, add it, 43. This is how you can simply get it. Again, simple dividing by 10, adding the modulo. I will show you in the code as well, but let's proceed forward. Here I realized that for the digit sum of 7, I don't have anything. So this also 43 cannot make a pair with anything in the past. Okay, no worries. Let's move on forward. As I move forward, but before that, I will update my digit sum. I will say 43. Now I am at this number 36. I will say, okay, its sum is 9. Do I have 9? Yes, I have 9. So I can make 36 paired with the maximum possible past number obtained for the same digit sum. So I will say, okay, let's say the current answer is, maximum of answer, comma, the current number which is 36 plus the past maximum number which is 18. Okay, and again, this is how I will keep on or trying to maximize. I will keep on trying to try and maximize stuff. Now, as I go on forward, because his job is done, I should make sure that for a digit sum of 9, I will update its maximum value. So here it will be updated. And now this indicates that for the digit sum of 9, in the past, the maximum nums of I is 36 and not 18. Okay. For 4, do I have something? No, I don't have something. Okay, no worries. Update that and don't update the answer. Let's proceed forward. Now for 7, I have the the corresponding digit sum as 7. I will firstly find for 7 as a digit sum. Do I have something in the past? Yes, I have. So technically, I can make 7 plus 43. 43 plus 7 can be my answer. Now, in this case, we can see 3, 4, and this will be 54. But obviously, this will be 51, which is less. So, my maximum answer is, still 54. It is not maximized by 51 because I have to maximize the sum. But as I'm trying to proceed forward, I can make sure that I'm updating it. But I see that for 7 already we have 43, which is more than 7. So don't update this also. So this will not be updated. So this will remain 43. Okay, let's proceed forward. Now for 25, I realize the digit sum is 7. In that case, make sure you check in the past what is the corresponding maximum digit sum. I realized I'll ask my map and it will say 43. So the current sum will be 43, which is this, and the current one, which is 25. It will say it is 68, which is max more than 54. Okay, updated. It will become 68. Okay, let's proceed forward. And again, before proceeding forward, I will try to maximize it by 25, but no, it will not be because 43 is already maximum. And then I will lastly go at this specific number 63. I will find the digit sum, which is 9. I'll go and check my hash map. What is the maximum value I have received so far? It will say 36. I will say 36 plus 63 will give me 99 and maximize my answer. Thus, I will get 99 as the value. And ultimately, this is how we can maximize it. So you see, I'm just maintaining, I'm just going to all the elements and I'm maintaining in the past what is the other, for the same digit, for the same sum of digits, what is the maximum element I have seen so far for it, and thus trying to make a good possible pair always. Cool. And again, you will see that this problem 2 7 is also roughly same, and again you can just go and watch it and make sure that you practice the problems. Let's see the code. It's pretty straightforward and simple. Again, I did not discuss these codes, brute force or this one, because again they, again to just implement this also is actually pretty big and not value for time, even money, like value for time itself. What's money here? Cool. Let's start off. As you see that I have a digit sum. Now I'm doing this in one pass, which means I did not maintain a separate hash map just for the digit sum previously. While I am going on to all the numbers, I am finding its digit sum. So I will say that the corresponding digit sum is 0. Then let's say I have to find the digit sum of 43, as I was mentioning. So I will keep on going and I will say I will make in my temp as 43. Then I will say until my temp is something, keep on trying. What I will keep on trying? Just get me the last digit. I'll get the last digit. So temp mod temp will get the last digit and simply add in your digit sum. So digit sum, I will add a 3. Then divide that by 10. So this will be divided by 10. 43 by 10 will become a 4. Again, the temp is non-zero. Yes. Get the last digit. Okay, get the 4. Get the 4. Divide by 10. It will become 0. Now temp has become 0. It will end here. If it ends here, now I realize my digit sum is 7. So I will check my hash map. In my hash map, for the same digit sum, do I have something in the past? If yes, then make sure that whatever I had something in the past, add it with the current number. This is how I can maximize my maximum sum. And before you proceed forward, make sure that you update your corresponding hash map with the maximum of either the existing value or the new value, which was nums. And then you proceed forward and go on to all the elements. With that, you will take O of n time, but again, this is O of n time one pass. You could solve this in 2 pass also, which people do, but again this is in 1 pass, which is more optimized. And because you are using a hash map for each digit, so this is for each digit, you are technically each sum of digit you are actually maintaining that. Now again, sum of digit can vary from, if you know that I mentioned that the value of nums of I is 1e9, which means I can start from the number 1 up till let's say 1e9. So if in the worst case I can have 9 times, which can say I can have this thing 9 times. So if I can have this thing 9 times, what will be the sum? What will be the maximum sum? Maximum sum will be 9 into 9, which is 81. So minimum sum of digit is 1, maximum sum of digit is 81, right? So I can have at max 81 options of this specific, like in the key, because key maintains sum of digit, sorry, this sum, this digit sum, and I realize the maximum digit sum is 81, minimum is 1. So with that, the space will be O of 81, or I can say also O of 1, because it is constant. Cool. I hope you guys got it. Again, it's easy, simple problem, but I tried to show you 3 approaches just so that you get the idea of how to approach any problem. Bye bye, take care.